Welcome back to the last video on electronegativity. So this is to do with solubility. Substances will dissolve in liquids that have the same polarity as them due to having matching intermolecular forces of attraction. This can be simplified down to like dissolves like. So we saw this before. Water, which is polar, because water has these negative charges on it and these positive charges on it, they surround the positive sodium atoms like this, with all of the water's negative charges lining up with the sodium, and they surround the anions like this, with all the positive charges on the water connecting with the chlorine. Make sure you understand this, because a very common exam question is to draw this, and you just have to draw something like this. Water molecules, which are these things with the hydrogens here and the oxygens here, surrounding your cation, because your cation's positive, so the negative part of the water surrounds it, and that is how, you see here, the cation has the oxygens around it, and the anions have the hydrogens around it. So the cation here is surrounded by the negative oxygens, while the anions, the negative ones, are surrounded by the positive hydrogens. Like dissolves like because this is a polar solid because they're charged, and this is a polar liquid because it's unevenly distributed charge. So we've got polar sodium chloride dissolving in polar water. Oil and water don't mix. Oil is non-polar and water is polar. So water is polar because it has this positive and negative charges, these slight charges on the atoms, while oil is made out of carbons and hydrogens, which are close enough in electronegativity to be considered non-polar, so they don't mix. There is no similar intermolecular forces to mix them together. It's nothing to do with density, it's all to do with if they're polar or not. Water is polar, oil is non-polar, so they do not mix because they're not similar. Like dissolves like. If oil was polar, then they would mix. So I said this. I made this slide last term. This will not make sense right now, but it will soon. Polar molecular solids will dissolve in polar solutions. Similarly, non-polar solids will dissolve in non-polar solutions. Like dissolves like. Sugar is a polar molecule, so it will dissolve in polar solutions like water. I hope this makes sense now. The reason why sugar is polar is because it has all these slight positive and negative charges around it due to the difference of electronegativities in the atoms in the sugar molecule. Lots of oxygens, lots of hydrogens and carbons, all with different electronegativities, creating these positive and negative regions. So we have water molecules surrounding sugar, and they can dissolve the sugar into it. I'm going to finish off today with shapes and polarity. So this will be really quick. Shapes, we've seen shapes before, and some of them are polar, some of them are non-polar. We're going to find out which is which. So we'll do this starter later, not important right now. Symmetry of shapes. Okay, I want you to note this down in your book as well. These are the 5 different shapes we've learnt: bent, trigonal pyramid, linear, trigonal planar, and tetrahedral. Some of these are symmetrical. The symmetrical ones, you put a mirror in the middle of them and they'll look the same on either side. They have symmetry. Linear, trigonal planar, and tetrahedral are all symmetrical. So let's try and pull some of these up if I can. This is a linear molecule. You see it's got this line of symmetry down here, meaning it's a symmetrical shape. Same with this one. This is trigonal planar. Its line of symmetry is down the middle, meaning it's symmetrical down the middle. If we take something like bent, it is not symmetrical. We could draw this down here, but it's considered a non-symmetrical shape because the charges are not balanced. It's all to do with the charges balancing out. So, here's our symmetrical shapes, here's our unsymmetrical shapes. Okay? This is very important when it comes to polarity, which we'll see for more of the shapes slightly later. But quick preview. Let's take something like carbon with 4 chlorines around it. We know it's got 4 carbon-chlorine bonds, all the bonds are carbene-chlorine, and this is polar bonds. So they're polar bonds. It looks like this. The shape's symmetrical, it's tetrahedral. All of the bonds are polar, with, remember, the arrow pointing to the more electronegative chlorines. But because the shape is symmetrical, the polar bonds cancel out, and so CCl4 is a non-polar molecule. We're going to get some more of these later on, but for now, thanks for watching, and I will see you tomorrow.